So now what does this work energy theorem says is, work energy theorem says that is work done by net force is equal to change in kinetic energy. That is, work done by net force is equal to kinetic energy final minus kinetic energy I for initial. That is, the work done by the net force onto a system is the change in kinetic energy of the whole system. Let's see, over here we have a block. Surfaces, they are horizontal, this surface is horizontal, frictionless surface, and over here there is a mass m and a force F is being applied in the horizontal direction. So obviously, that is, there is no friction, so F is equal to ma, so this implies acceleration is going to be F by m. Now we say that is v square minus u square is equal to 2as. Suppose because of this force, this body has moved through a distance s. So obviously, v over here at this, after a distance, traveling a distance s, it has a velocity v. So we say v square minus, initially it was at rest, 0 square is equal to a. A is what? F by m into s. F into s comes out to be half mv square. F into s, that is, they are in the same direction. So the work done by this force is represented as the change in kinetic energy of this body. Now if we have more forces than one force, then still is it applicable? That is, the work done by the net force is equal to change in kinetic of the body. Let's see. Let's say there is a body of mass 2 kg. From here a 10 Newton force is applied, and from here 4 Newton force is applied, and the body has moved, let's say, from here to here a distance of 6 meters. So now we are going to see whether the work done by the net force, whether it is equal to change in kinetic energy of this body or not. Initially it is at rest, so initially we say u is equal to 0, and over here when it comes over here, let's say it has a velocity v. So we can see that is 10 Newton minus 4 Newton. Onto this body there is a force of 6 Newton in this direction. 10 minus 4, there is no opposite direction, so that's why the forces will get deducted. So this is 6 Newton being applied on a body of 2 kg. So force is equal to mass into acceleration. Acceleration comes out to be 3 meters per second square. So after traveling a distance of 6 meters, because acceleration is constant, we can directly use the equation of kinematics. So it means we can use v square minus u square is equal to 2as. So it means v square minus u square is equal to 2 into a is 3 into 6. So this comes out to be 36, or v comes out to be 6 meters per second. If we are interested in what is the change in kinetic energy, so obviously initially it was k, kinetic energy initial, that was 0, and kinetic energy final is obviously half m. M is what? 2 into v square is 36. So this is going to be 36 joule is the kinetic energy final. Now let's see what is the work done by the resultant force. The work done by the resultant force is, what is the resultant force? Resultant force is 10 minus 4, that is 6 Newton in this direction. It is in this direction. Displacement is also in this direction. So when we say that is work is equal to dot product of these two vectors, F dot S, force is 6 Newton in this direction into displacement is also in this direction. Angle between the two is cos 0. Cos 0, you know, that is 1. So work is 6 into 6, that is 36 joule. It comes out to be the same answer, that is the change in kinetic energy of this body. Also, if we are otherwise also you find that is what is the, how we add the work. Work is a scalar quantity, so they can be algebraically added, subtracted as we do. That's 2 plus 3 is always going to be 5. Whereas if we talk the vectors, like a displacement of 2 meter plus a displacement of 3 meter, it may not give a displacement of 5 meter. But if we talk about the distances, the distance of 2 meter plus 3 meter is always going to be 5 meter. If a body has gone from here to here, at 2 meter it has gone from here to here, then it has gone from here to here 3 meter, then the displacement is this, from initial to final. This is not going to 5, whereas the distance is the total length, 2 plus 3, that is always going to 5. So vectors, they are added vectorially. They follow the vector algebra principles. So now work is a scalar quantity. Let's see, that is, whether we can algebraically add or subtract it in a simple manner, what we have been doing. Now the work of this force, let's say work of 10 Newton force is, what is the work of 10 Newton force? 10 Newton is being applied in this direction, 6 meter is also in this direction. So it is 10 into 6 into cos 0 is equal to, that is 60 joule. Now the work of 4 Newton force, 4 Newton is in this direction, 6 meter displacement is in this direction. So 4 Newton is in this direction, 6 meter is in this direction. So angle between the two is 180 degree. So work of 4 Newton is force into displacement 6 into cos 180 degree. Cos 180 is minus 1. So 6 into 4, that is minus 24 joule. So the total work done onto the body by which forces? By this and this force only. There is no work done by mg or normal reaction, because mg and normal reaction, both the forces, they are perpendicular to the direction of displacement. So work done by those forces will be equal to 0. So work done by this 10 Newton and 4 Newton, simply algebraically add it. So 60 minus 24 is 36 joule. So work energy theorem says the work done by the net force is equal to change in kinetic energy of the system. Let's understand it further by taking few examples.